is correct according to, what is this, what do these words look like as an equation?
I said B.
G?
I said B as well.
Good. Awesome. And then what does M equal?
5.
Does everyone agree with Kaylee? M equals 5. We're going to subtract 4 from both sides. Or sorry, we're going to add 4 to both sides. Yeah, because it's -4. Yeah, my bad.
That's what
Yeah.
What if I did subtract 26?
Yeah, I mean, it would work.
Will it work both ways?
Well, I mean, you would still then have to still move your terms back over to the other side of the equal sign, but yeah, right? Because you'd have to subtract 26 from both sides, so then you'd have 6m minus 30 equals 0, and then you'd have to add the 30 back and then divide. So
That's what I.
that's fine.
How did you get 5? I got 10.
Okay.
It's 30 right now.
So no, because I'm just gonna add, I can only add 4 and it only combines with this term, right?
Oh, you add 4. 4.
Yeah.
Adding 4.
You can't add it to 6m because they're different terms, right? So then 6m equals 30, and then we divide by 6.
Okay.
So don't forget your steps, right? Once you know that you've got your equation set up, then, right, start with whatever's being added or subtracted, do the opposite, and then whatever's being multiplied and divided, do the opposite. And that should give you what your variable equals. All right, hopefully everyone feels good about this, and definitely GED test questions where, yeah, you'll have to choose the equation, okay? And interpret, right? Basically translating words into numbers and mathematical operators. Okay, number 32, if Jolene adds 5 stamps each month for 8 months, she will have twice the number of stamps she has now. Which equation can you use to find the number N of stamps Jolene has now? See?
I wasn't sure about this one, so I chose B.
So 5 stamps a month for 8 months
2 times the number.
is gonna give us, right, is gonna equal, right? Twice as many as she has now, 2n. So yeah, I think it's C. Yeah, does that make sense? Because here's how many stamps she has to start. And then she's gonna add 5 for 8 months.
Oh, okay, that makes more sense.
And then she'll have twice as many as she currently has, right?
So how do you bring those down? That you have to multiply that into 5.
Yep, so then to solve, right, we're gonna just do a little bit of, so then we have n plus 40 equals 2n, okay? And then I see that I have like terms on either side of my equal sign. So I'm gonna go ahead, my n is smaller than 2n, so I'm gonna go ahead and subtract n from both sides. 40 equals n, right? 2n minus 1n is n, so n equals 40. You remembering how to solve the equations?
I got, so I chose B, right? And I got the same answer, 40.
Because
Because I did 2n plus
I mean, I
8 times 5 equals n. I did 8 times 5 equals 40. So then I just brought everything down. And then I did minus n on both sides because they're like terms. So that I just put a 1 right there. 1n equals 40. So then I divided both sides by 1. I got 40 still.
B, I would have 2n plus 40 equals n. It's gonna be negative, right? If you do B.
Yeah. I don't. Okay. So it'd be negative 40.
Yeah,
You're right.
and I don't think Jolene can have a negative number of
Yeah,
stamps.
probably
Look at how many like less than 0 stamps I have, guys. Yeah. I have so few stamps I have less than. No worries though. Good question. All right, everyone feel okay about 32 now? Okay. Let's look at 33. So, oh, and I guess I didn't really underline that first chunk, but we have 5 times the quantity, x minus 1, equals 3 times the quantity, x plus 9. So what is our equation?
5x minus 1 equals 3x plus 9.
Well, it's 5 times the quantity, x minus.
Oh, I didn't see that.
So what does that look like? 5 times, not x minus 1, but 5 times the. So anytime you see the quantity, right, parentheses, x, right, equals 3 times the quantity, x plus 9. See how that works? So yeah, right, when you see this, the quantity, then that means that, right, this gets put inside parentheses. Does that make sense? I think we saw this on Monday.
Yeah.
So now that we've got our equation written out, right, their first step is to distribute the 5 into here and distribute the 3 into here, right, to simplify and get rid of the parentheses.
Would it be like 5 times x, 5 times 1?
Mhm. Yep. Right, so if we simplify this, then we have 5x minus 5 equals 3x plus 27. Does everyone feel good about how I went from here to here? Yes, no, maybe so? Because all I'm doing is multiplying my 5 by everything inside the parentheses. And once I do that, it makes parentheses go away, which is a lot easier to work with, okay? Then, right, I see that I have like terms on either side of my equal sign. So I'm gonna need to combine them, and I always find the smaller to combine. So let's subtract 3x from both sides of our equation. Right, and so then we end up with 5x minus 3x is 2x minus 5 equals 27. Okay, what's my next step now that I've got 2x minus 5 equals 27?
1, 2, subtract 5 from both sides.
Not, it's already subtracted, right? Minus 5. So
You're gonna
add
both
5. There we go. There you go. No worries. Good. All right. So then that's going to cancel. 27 plus 5 is 32. So 2x equals 32. Then just divide both sides by 2. So x equals 16. Right. 32 divided by 2. Do you guys want to try 34 now that you have this model to kind of look at, or do you think you got 34? All right, so if we look at number 34, okay. 4 times a number n, right, 4n, minus 3 times the sum of the number plus 2 is equal to 5. Is that what you guys got for 34? So either it's going to be called the quantity, or it's going to be the sum of something and something else, right? So when it says like the quantity blank or the sum of, right? Sum of a number. Okay, does that make sense? So if this is our equation, what's our first step to solving it?
Distribute the three.
Good. Right, so we're gonna take 3 times n, or actually negative 3 times n and negative 3 times 2. Make sure, remember that negative stuff in there. So then we have 4n minus 3n minus 6 equals 5. Okay, so here my n's are already on the same side, so I just subtract them, right? 4n minus 3n is n minus 6 equals 5, so n equals 11. Just gonna add 6 on both sides. Okay. How did that one go for you guys?
It was good. I was just a number off.
Okay. But you did, your setup was kind of similar?
Yeah.
Good. All right. Good. Okay. Letitia has a coin collection. If she adds 5 coins each month, the size of her collection will triple in 2 years. How many coins does Letitia have in her collection now?
Might be wrong, but I got 360.
Okay. What was your equation?
Well, I did 5 times 24,
Okay. Good.
and then I tripled it.
Okay.
That was right.
All right. So good. So Chris did a good job, right, of noticing that, right? So here, if it's every month and we know the total number of years, right? Then we know that, yeah, right? So she's got her coin collection plus, right, 5 times 24, right? So this is her current collection of coins. She's going to add 5 coins a month for 2 years or 24 months. And that means that after those 2 years, she'll have tripled, right, her collection. So it'll be 3C. So now we can see how we did here. So you said 5 times 24 is 120. After you're good. Yeah, no, after, because 5 times 20 is 100. Yeah, 5 times 24. Yeah. All right. So then I have C plus 120 equals 3C. Got like terms on either side of my equal sign. So I need to combine those. So C is smaller than 3C, so I should subtract the C off of both sides. So then I have 120 equals 2C, right? 3C minus 1C. So it looks like C equals 60.
You only have 60.
Yes.
I think we got 360 because he tripled it for 2 years from now.
That's. Oh, goodness. Okay, so yeah, Chris, I'm not exactly sure. Like I said, I just had to kind of set it up, at least work it out how the problem's telling us. But
5 coins each month for 2 years. is way more than 60 coins.
this is how many coins she's starting out with before she's starting to get her 5 coins.
Oh,
So this is her initial number of coins. And right after,
oh, okay.
right, and then after the 2 years, she'll have a total of 100. Or 180, sorry, right? Because over the 2 years, she's gonna collect an additional 120. So then when we added 60, you get 180. So at the end of 2 years, her coin collection will have tripled from 60. So yeah. Okay. Alice, John, and Kim worked together on a painting job. John worked 8 fewer hours than Alice. Kim worked twice as many hours as John. If the total hours worked on the job was 72, how many hours did each person work? And then the hint is let each hour be the hours worked by Alice. So we kind of have to figure out how much did John work and how much did Kim work, but we have to think of it in terms of Alice's work. Does that make sense? So for me, right, so John worked 8 fewer hours than Alice. So once again, right, we can kind of set this up in that Alice, right, is just H hours, okay? John worked 8 fewer hours than Alice. So John worked 8 minus 8 hours. Does that make sense? And then Kim worked twice as many hours as John. So 2 times H minus 8. Does that make sense? Right, and then the total was 72, so we have H plus H minus 8 plus 2 times the quantity H minus 8 equals 72. Does that sound okay? So what's our first step in solving this equation? Distribute the 2, good. So, right, this is going to become 2H minus 16. And then, right, I have a, put everything else down. Okay, now I have 1H, 2H, 2H, so that's 4H, right?
Mhm.
And then minus 8, minus 16, negative 24. So now I have 4H minus 24 equals 72. Does everyone feel good about going from here to here?
Yes.
Okay.
I know.
I've combined my like terms. They were all on the same side. So I didn't have to do any like, you know, opposites. Okay, so then let's add 24 to both sides. See if this works. 60, 96.
I got 98. Oh, I did something. I'm just kidding.
Okay. Sorry. And then 96 divided by 4 is 24. So we know that H equals 24. So that's how much Alice worked, but how much did John work?
Eight times.
Well, no, H minus 8, so 24 minus 8. 16, right? And then how much did Kim work? She worked the most, right?
16%.
Yep, which is 32. Yep. And then if we add these up, 24, 16, and 32, it should equal 72, right? Why is John so lazy, making the ladies do all the work? That's my question. Sure, John was very. Okay. So how's everyone feeling about these problems? Do they feel doable? Where do we feel like they're? I mean, Kaylee just needs to get her numbers right, which I mess up all the time. So, but how does everyone feel about the setup? Is it still just feel like really impossible to interpret, or?
When I first started 36, I was very confused by it, but now that you've walked through it, I learn.
Yeah, and these ones are, yeah, they're just tedious, right? Kind of more than anything. And so, yeah, usually I like to, and I mean, the hint is helpful as well, right? So usually if you kind of have 3 different pieces, we're always thinking of the other 2 in terms of 1, right? So yeah, that definitely kind of helps to walk it out, okay? But of course, I mean, without this hint, it would have been maybe challenging. So is Alice who we should focus on, John, or Kim? And you could maybe do it the same way, but not really, because like you don't have any information about Alice. So I guess that lets you know that you have to think about her as the unknown.
I like the way it's spoken now.
Yeah, I have. I'm pretty sure that's like. Any other questions, comments? Everyone feeling okay? All right, well, we'll keep trying to practice this stuff as much as possible, because I would say this is very GED-like, okay? So sometimes it'll be like 31 where you'll just need to find the equation that matches, and other times you'll have to create your own, work it out. Okay, awesome. Is there any other pieces you guys feel like we need to practice? Okay. All right, let's just do a little bit more on these ones now that we've kind of talked through them a little bit. So go ahead and just work on 1 through 5. Okay. And see now if, because we talked about things, you feel like, you know. Okay. So April, you think you just need more practice, or do you think we need to kind of break it down and keep working through it together? What do you think might help you? We're still warming up a little bit, Spencer, so we're just working on 1 through 5 here. Once you get settled back in. I don't have a paper for me. You need a piece of paper? Sorry. Give me one copies. Give me something.
I think she's a river.
If you divide the number 4, you divide the number by 4 and add 11 to the quotient, which becomes your original number. So divide the number by 4. And then the quotient is just the answer you get once you do the dividing. So
See,
no, because that means that the 11 is being divided by both the 4 and the n, and here it's only just dividing by 4. We're adding 11.
okay, so you-
Mhm. Good. Pardon?
say my brain's all lost right now.
Uh-oh, scrambled. Uh-oh. I know it is a lot and, yeah, can be a lot of noise. We'll see, we'll talk through them and hopefully it'll click a little bit again. All right, you guys need another 2 minutes or so? Please. Hi Joshua, glad you could join us. I'll go ahead and put the attendance sheet link in the chat. Curtis, you should also click on that link in the chat and fill out your attendance sheet too, please.
New tests, what do we have to take, was it 5?
Yes. There are 5 GED tests.
Studies, science, history,
Language arts,
art.
histories and social studies
And civics.
and civic. So, yeah, we'll have 2 weeks of class after this week, so probably not next week, but the next week. We'll start kind of looking at your progress tests, and then also we can work on some actual GED ready tests. Going into a week break before our fall classes start, so we'll see how, kind of check in and see where everyone's at. Running up toward our little short break, and then we'll say, maybe you're GED ready, maybe you benefit from more class. Does that sound like a good plan? More or less, so. Okay, yeah. As much as I love having everyone in my class, it's much better when you have good reasons to not be in
So close to.
I know, we're gonna work on that. Okay, let's go over these. So 4 times the number plus 2 is equal to 2 times the same number plus 8. So I'm just gonna use an X. So hopefully everyone agrees. 4 times the number plus 2 is equal to 2 times the same number, right? Our X is our same number plus 8. Okay, then of course, I have like terms on either side of my equal sign, so that's what I need to deal with first. So I'm gonna subtract a 2x from both sides of my equation. Gonna cancel. So now I have 2x plus 2 equals 8. And then I'll subtract the 2 from both sides. 8 minus 2 is 6 equals 2x. Divide both sides by 2. X equals 3. So the answer number 1. You guys get that one? And just think about where you feel like you get stuck. Is it the making the equation part, solving the equation part?
I ended up with them.
Okay.
4 times and put it in 4 plus 2.
4 times x plus 2?
I put this 4 plus 2 in parentheses around them, but I thought you were supposed to multiply this.
Okay, yeah, and of course, the other thing to always be looking for, right, is right, knowing where the variable is, right? So if it's just 4 times a number, then that's where you know where your variable is gonna go. And yeah, that's definitely another,
It said multiply 4.
yeah, 4 times the number is like 4x. 4 times x, yeah.
But if it said multiply before the 4, then I.
So if it was like 4 times the quantity or 4 times the sum of a number plus 2, that's when, yeah, and it's definitely a challenge. So hopefully if we look at some more, you'll get a sense of that. But really, right, I'm just pretty much straight up reading the sentence. 4 times a number plus 2 is equal to 2 times the same number plus 8. Yeah, it always does, unfortunately. And it just makes sense all the way. All right. Number 2, now number 2, right, we have a fraction, right? So 3/4 of an amount. So now instead of a number, Chris, right, it's an amount, but it's still our variable, right? So 3/4 of an amount, and I'll just call it X again, plus $150 is equal to twice the original amount. Did you guys get that piece? Good, all right. So then, unfortunately, right, I've got x's on both sides. So I should subtract a 3/4 x from both sides. So then I have 150. What would that be as a fraction? 8/4, so 5/4. Yes. X. Okay. 2x minus 3/4 x is 5/4 x. Does everyone feel okay about that? So then because, right, my x is being multiplied by a fraction, how do I deal with that? Kind of, how do we divide it?
So
Yep.
it's 1/5 times.
Yep.
5. Okay.
Exactly, right? We take the reciprocal, so we're gonna multiply by 4/5 to both sides. You guys remember that? Good. Okay, so we got, right? 5/4 times 4/5 leaves me with 1x. Right, because 5 times 4 is 20, 4 times 5 is 20, 20 over 20 is 1. Then here, I can see that I can cross reduce, right? I can take a 1 out of here. Let's see, 150, I think it's 15. No, it's 150 divided by 5 is 30. So then 4 times 30 is 120. How's that one feel? Get that? Woo. Number 2, so this is, or sorry, number 3 was kind of like, right, the Alice, John, and Kim, but now we just have numbers, right? So 3 numbers add up to 64, right? So we have number 1, number 2, and number 3, okay? So the second number is twice as large as the first. So similarly, right, we're gonna call number 1 number x, right? And then the second number is twice as large as the first, so it's 2x, right? And then the third number is 3 times larger than the first, right? And then we go back to our beginning, right? The 3 numbers, x plus 2x plus 3x add up to 264. Okay. So I've got all these like terms on this side, right? So 1 plus 2 plus 3 is 6. And then let's just divide both sides by 6. So the first number is 44. The second number is 88. And I have no idea what 44 and 132. So let's see here. 132 plus 80. Okay, uno otra vez. 44 plus 88 plus 132. So the 3 numbers are 44, 88, and 132.
Just did 88 plus 88 plus 88. I honestly saw the first sentence. I'm like, oh, I got this.
That's good.
I get what you mean.
Okay. Yeah, there's generally always gonna be an equation that you should be. Okay. I don't know where Anna and Joe went to lunch, but I need to find this restaurant. Like, man, I wish I could spend $8.35 for 2 people's freaking lunch. What did they have? A cup of soup? Something like that. All right, so we know the total bill is $8.35. Okay, and we know that Anna's lunch costs 65 cents more than Joe, right? So we have X plus 65 cents plus X. Does that make sense? Because this is, right, this is Joe's lunch and this is Anna's lunch, right? Of course. Does that make sense to everyone? So then we can combine our like terms. So 8.35 equals 2x plus 0.65. Then we'll just go ahead and track this off. So what is that? 770? 8.35. So then we have 770 equals 2x. So we'll just divide both sides by 2. So Anna's lunch cost $3.85. Yeah, $3.85. Right? Or no, that's Joe's lunch, sorry. And then Anna's was 65 cents more. So her lunch apparently was $4.50. Just about $4.50. Yeah. Wendy's doesn't really have $1. Wendy's are $1.
When you got that $4 or $5.
Oh, yeah, that's right. 4 items for $5.
Quality is definitely.
Yeah. Oh, they have the breakfast sandwiches.
I got $3.54 and $4.78.
Oh.
I just divided,
Divided what?
so, or what did I do? I did. 2 and $8.35 and I got $4.16. So then I just took 62 cents away. Or 65 cents away. I think I did 62 cents instead of 65, so
Okay.
that's maybe why.
Probably, and then, yeah, right, if you cut 8.35 in half, then you have half of a cent, which is annoying to work with, well, technically impossible, but mathematically plausible. But yeah, really, hopefully everyone's just feeling like you're able to pick out, okay, what is the unknown and then what's happening around it that I can use to make it into an equation that I can solve. All right, so then we already talked about 5, but hopefully everyone agrees that the answer is D, right? Divide the number by 4 and add 11 to the quotient. And quotient is basically the outcome of a dividing problem. So, and of course, if you were gonna follow the order of operations, right, you would do the dividing and then the adding. So hopefully that kind of makes sense. And then the number that results, right, is our equal sign. And the number that results is equal to 3 times the original number. So the answer is D. Okay. How would we want to do it? Okay. Questions, comments? How is this feeling for everyone? Better, worse, same? Well, let's take a break. Let's take a 10-minute break and then we'll get back into it. So, oh, sorry guys. I'll leave that up there for you, but yeah, let's. I know, that's pretty cool looking. I don't think so. Just the top one. So yeah, we'll take a break till about 2 o'clock or 2:10. All right. Let's take a non-break break.
Who's that?
That's what I'm saying, break until 2 p.m., but it's 2 p.m. So then, oh wait, no, 2:10. Take a 10-minute break. We all clearly need it. So yeah, I'm not sure, Kate, like for me, I guess I always am assuming that it's an equation rather than just trying to work with the numbers I'm given, so.
Yeah.
While I don't think it's an awful strategy, because it might work, I just have to figure out how to teach it and how to make it click in my brain, so I could explain it better.
I understand that. I think my biggest problem is trying to figure out this thing. It's okay, I'm really fast at solving it and getting it right.
Yeah.
A lot of times, but making the actual thing really confusing.
Yeah, I would definitely say that that is a challenge.
Do you have them to go with it?
Oh, great. Let me go grab it.
Okay, thank you. I just want to show my grandpa I got it right, so I get $100.
Okay. Oh, yeah, well, that's definitely.
Yeah.
And the Earth is speeding up, causing us to have shorter days. We had the shortest day recorded in history on July 29th. 1.59 milliseconds off the approximately 24-hour day.
Interesting. Are they saying what they think is affecting it?
No, they're saying it's odd right now, they're not sure. Oh, and that can't for sure. Want to see a university testing, so. July 26th. Oh, the day felt short.
All right, just one second. Okay. Let's get to it. All right, let's see where we left off on Wednesday, or on Monday, excuse me, on our basic algebra. Working on the lesson 9. Oh, maybe we finished lesson 9, actually, it looks like. But it might be on lesson 10. All right, so. All right, yep, looks like we're on lesson 10. So let's go to there. So it says page 20 down in the bottom left corner. And hopefully everyone can find the spot. So yeah, pretty close toward the end. 10 of 14 lessons. So, okay, let's see what we've got. Okay, I think we've been kind of doing this a little bit when we've been combining like terms, but we're going to kind of keep using those skills to kind of manipulate our equations when we're trying to find something specific. Okay. All right. So let's. You don't have. Yeah. Actually, I think you just remembering to Tuesday, Thursday, not right? Yeah. No worries. Thank you for letting me know. Just got one more out. Awesome. Okay. Cool. All right. Any of you folks in chat need a link to these materials? We've been working on them for quite a while, so I feel like most of you guys should have them. Okay. When you solve an equation, you use inverse operations to isolate the variable and find its value. Okay. So hopefully that sentence makes sense, right? We all know, right? Inverse operations, right? Adding versus subtracting, multiplying versus dividing, squaring versus square root, but that's not too important right now. Okay. And then of course, when you think about isolating the variable, right? That means we're using inverse operations, right? To get our X or whatever by itself, and then its value, right? What does X actually equal? The same method can be applied to equations and formulas that have more than one variable to rearrange the parts or to solve for a particular variable. Okay. And I don't think this vocabulary is super easy, but yes. Okay. So we're focusing on this rearranging so that we can solve for a particular variable. That's our goal. All right, equations with several variables are called literal equations. I don't think we need to know that word. So let's jump to our examples, okay? So the volume of a sphere with a radius r is given by the formula. The volume equals 4/3 times pi times r cubed. Okay, does everyone know what a sphere is? No, what makes it? Well, circles and ovals are 2-dimensional. So what's the difference?
Oh, it's.
Spheres are 3-dimensional. So I always think of a sphere as a 3-dimensional circle, I guess, or like a circle's 2D, right? So any ball shaped thing, right, is a sphere. And so what does it mean when we're going to calculate the volume? What does volume measure? Kind of? Although things can have the same volume and have different masses, right? Because if I have a liter of air and a liter of water, right? Liter of water is gonna be the same, so even though the volume is the same. So does anyone have a sense of what volume? So volume is really just a measurement of the space the three-dimensional shape is occupying. Okay? So of course, when you think about a cup, especially like a measuring cup, right, you're using that to get a certain volume of liquid ingredients, right? So you need to measure how much volume you need. So volume is a measure of three-dimensional shapes. So we can find the volume of cubes, we can find the volume of cylinders, we can find the volume of pyramids, spheres, boxes, okay? And so for each type of three-dimensional shape, there's a specific formula that applies so you can calculate the volume, okay? And so formulas are equations, right? But they're more like recipes to calculate something, right? Usually what's alone on one side, right? Usually trying to calculate. Okay, and so once again, to calculate the volume, the V volume of a sphere, so big V stands for volume. Okay. Okay. And then it equals 4/3 pi. Does everyone know what pi is? Okay, so this is the little Greek letter that we use to represent a number. And so pi is the number we need to have, and we have to use when we're dealing with anything circle-like. And so pi approximately equals 3.14 or 22/7, but pi is also one of those numbers that basically the decimal points go out to infinity and they don't repeat or anything. So some people can memorize pi out to like inch numbers, but anyway, it's just it just represents a number. I'm not sure what else to tell you. And then the last part of the formula is R. R stands for radius. Does anyone know what a radius is when we're talking about a circle or a sphere? Almost. That's the diameter. So the radius is half the diameter. So the radius, you start in the very center, and it's the distance from the center of the sphere circle to the edge. Yeah. Yeah. Right. So the diameter goes from end to end, but the radius goes from the middle to the outside. Yeah. So cool. So in order to know the volume of the sphere, we have to know the radius. If we don't know that number, we can't calculate it. We can't calculate the volume. Okay. Now, of course, what the GED likes to do is tell you the volume, and you have to figure out the radius, because of course, it's the test. So here, this formula gives the volume in terms of the radius. Does that make sense? So when we say V equals 4/3 pi r cubed, we're talking about the volume in terms of the radius. Okay, so they want us to rearrange the formula to solve for the radius in terms of the volume. So we're not solving anything. We're just going to take our formula and rearrange it so that R is now alone on one side of the equal sign instead of the V. Okay. And once again, this would be right. If we knew the volume and we needed to know the radius, well, then we could rearrange the formula so that we can solve for R instead of solve for V. Now, this looks really confusing, and I'm not quite sure why they always give us such hard examples to start with. So we need to solve the equation for R, okay? So, right, we need to get R by itself on one side of the equal sign, okay? So what do we do? First, isolate the R term on one side of the equation. So the first thing we have to do, right, is get rid of our 4/3. And so we know, right, to take the reciprocal of 4/3, which is 3/4, and multiply that by both sides, right? So it reduces. So now that I've gotten rid of my 4/3, now I have 3 times the volume divided by 4 equals pi r cubed. So now I should, right, move my pi over by dividing both sides by pi. So see, now that I've divided both sides by pi, now I have 3 times the volume divided by 4 times pi equals the radius cubed. Okay, and then to undo the cubing, you have to take what's called the cube root, which is this here. It's a square root sign with a little 3 there. And so we know that if we have the volume and we need to know the radius, you can write then this transformation of our original formula to solve. Okay? How confusing is that? Very confusing?
These are the questions I didn't.
Okay. Okay. Good to know.
I done this in high school before I left, so. it was
Good.
pretty easy.
But yeah, I would definitely say that, yeah. So does everyone see like what we're trying to do here at least? So we're starting with this formula. It has 2 variables. It has a V and an R. And this version of the formula tells us how to find V if we know R. But we can use our fancy algebra rules to rearrange this original formula. So now we know that R equals the cubed root of 3 times the volume divided by 4 pi. I don't think we'll have any questions quite this hard with like cube roots and stuff. I don't think we'll have to hopefully deal with that. But let's look at example 2 because this one looks
Target says they want to do the right all out. but there's no
interesting.
options for them.
Okay. Okay.
That's okay.
So was the question literally something like rearrange the formula to solve or like how
Was that symbol on the answer with the check kind of,
this cube root?
Yeah, that was in front, no, it was like the letter, it was number and then that thing, and then
Mhm.
that like equal. I
Okay.
can't remember exactly.
Yeah, definitely when we get to exponents and radicals, yeah, it's more of that math that like, it's not hard if you, of course, know what to do, but if you don't know what to do, then it's, yeah, you're pretty much kind of stuck, unfortunately.
that's why I was so close. I probably got those questions right.
Okay, well, hopefully then we're on to the areas that will help you. Let's look at this next one. So here we have another formula. Okay, so this is the formula for the area of a trapezoid. Does anyone know what a trapezoid is?
So,
That's a trapezoid.
no,
Oh.
like a floor, right? And the-
No, I think you're thinking of a protractor to measure an angle,
Yeah.
maybe. Does anyone know what a trapezoid? The kind of quadrilateral.
that was-
So it's a well, okay, so compared to a sphere, a trapezoid is 2-dimensional. And usually it looks like this. So it has the 2 sets of opposite sides are not parallel, and then 2 of the sides are parallel. Okay. Right, so a trapezoid is a different shape from a rectangle, square. Okay. It's a 4-sided shape though, okay? So to find the area of a trapezoid, you take 1/2 B1 plus B2 times the height. So on our trapezoid, B stands for base, A stands for area, just like B stands for volume, A stands for area, okay? And so on our trapezoid, it's the two parallel sides that are the bases, okay? So we need to know the length of this side and the length of this side. Okay. So if I know the length of B1, then I plug it in here. If I know the length of B2, I plug it in there, multiply it by the height, and then, now the height of the trapezoid is a little confusing, but we can't use the slanty side. We have to basically imagine a line coming straight down, forming a 90-degree angle here, and that's the height. So it's from base 1 to the top of base, well, from the top of base 1 down to base 2 is the height, okay? So once again, does everyone know what area, when I'm calculating area, what am I calculating? The sides. So, well, if I said the sides, makes me think of perimeter. Right, perimeter is the distance, the total distance around the outside, right?
Isn't the area trying to find how big it is in the middle?
Yeah.
Or inside or
Yeah.
whatever?
So the area is the total amount of space that the shape takes up. Right, so in order to know what the blue shaded area is, we have to know the length of the base 1, length of base 2, and the height of the trapezoid. Okay, now what they want us to do is take our formula and isolate B1. So it's like we know the area, we know the length of one of the bases, and we know the height. So we need to know the length of the other base. Okay. Sorry, Eddie, is it too small?
No, it's good.
A little bigger. Okay. So hopefully everyone sees, so B1 and B2 are different variables, right? They're not the same quantity, and that's why it's sub 1, sub 2. Okay. All right. They represent the different bases of the trapezoid, of course. So to isolate B1, first multiply both sides of the equation by 2, right? That gets rid of our 1/2, right? The opposite of dividing by 2 is multiplying by 2. So then we have A equals B1 plus B2 times H, okay? So then to get rid of our H, we divide both sides by H, okay? And then subtract both sides by B2. So now we need to know if we need to solve for B1 and we know the area, the height, and the length of B2, we can solve for B1. Okay. Does that help build from example 1 to example 2 what we're doing? Really just using our algebraic rules, not to solve for anything, but to rearrange the equation so that we can isolate a different variable if we want. And this is definitely something that is not necessarily super applicable in math, but it very much applies to science, geometry, where you have lots of formulas and stuff. Okay. All right, let's look at example 3. So once again, hopefully it's just making sense to everyone how to kind of manipulate these things, but it's not the easiest. All right, one formula that electricians use for effective resistance for 2 parallel circuits is 1 divided by, I have no idea what R sub T stands for. Oh, maybe it's the resistance transfer. I'm not sure. Anyway, we have 1 over R sub T equals 1 divided by R sub 1 plus 1 divided by R sub 2. All right, too many R's are confusing, so let's change to A, B, and C, okay? So multiply each term by the common denominator, which is A, B, C. So we have 1A times ABC over 1. 1B times ABC over 1. Okay, so right, we're just doing that. We simplify it down, we get BC equals AC plus AB. Does from here to here make sense? So, right, because here my A cancels, here my B cancels, here my C cancels, right? So now I have B times C over 1, which is the same as BC, right? AC over 1 is the same as AC, AB, right? So yeah, does this make sense how the common denominator amongst A, B, and C is ABC? Right, because we have to have each of the terms in there, right, so that they'll cancel. So we're still solving for A. We don't have A by itself. We have to factor out an A. So we get BC equals A times the quantity C plus B. Then we divide each side by C plus B and replace the substituted variables with the original. So our answer is A equals B times C divided by C plus.
I'm happy they switched
Pardon?
it. I'm kind of happy they switched it to A, B, and C.
Yeah, it would have been really confusing with ours, our subs, whatever. Yeah. So yeah, hopefully we'll get some more practice with this. Like I said, don't worry too much, but definitely just be aware that a lot of times on GED math, you'll have a formula like this, but instead of having to solve for the easy variable that's all alone on one side of the formula, you're probably going to have to solve for one of these pieces. Okay, so you don't have to necessarily transform it, right? You can just plug it in and still work through it. So hopefully that makes you feel a little bit better. All right, let's look at example 4. The ratio of flour to sugar in a muffin recipe is 5:2. The equation S over F, right? Sugar to flour equals 2/5, models the amount of flour F and the amount of sugar S that should be used. So solve the equation for F. So start by cross multiplying to clear the fractions. So, right, cross multiplying, so 5 times, or S times 5 is 5S, 2 times F is 2F. Okay, so now I have 2F equals 5S. Then divide both sides by 2. So I know that, right? My flour is always 5 halves of the sugar. Not that that's very helpful. Did this transformation make sense? From here to here? Good. All right. Let's look at the practice on the next page. Okay. All right, and let's talk about number 1 together. All right. So we have the equation 3x plus 2y equals 6. And we need to solve for y, right? So that means we need to get y all by itself, right? So we need to start moving. We need to move this term and we need to move this term, okay? Right? To get y by itself. Okay, so how do I get my plus 3x? How do I move it over? This is plus 3x. I need to move this, the 3 and the x all the way over here. So I'm just gonna subtract 3x, right, from both sides. Plus 3x minus 3x cancel, so now I have 2y equals 6 minus 3x. Does this step make sense? Right? So it's like combining like terms, but they're not like terms. We're just moving them to the other side of the equal sign, but we're still doing the same thing. It's just, it doesn't combine anything. It's just now on the other side. Okay. Then, right, to get rid of my 2, since this is 2 times y, then we're going to have to divide, and we're going to have to divide both chunks by 2. Okay. So of course, 2 divided by 2 is 1, so I'm left with 1y. 6 divided by 2 is 3. And then, right, I can't really simplify 3 halves. So does this make sense how I've just isolated the y on my one side? I haven't done any solving, but I'm just rearranging the equation. Does that feel doable? Yes. The steps make sense, how we got from here to here to here? Pardon?
You did it perfect.
Oh, well, gee, I hope, I try.
Yeah, pushed my
Okay.
mind.
And yeah, and I mean, it's really just useful, right, to be able to begin to think about how we manipulate these things, how we move stuff around, or how you can move stuff around to hopefully try and make things easier for you. So of course, now if we knew what x equaled, then we could just plug it straight in, follow the order of operations, and we'll know what y equals. All right, number 2. You guys are welcome to try. Go ahead and just read through the remaining practice problems. Try the ones you think you feel okay about. If none of them, after you kind of read through them, think about them, if all of them are feeling horrible, let me know. So the other measurement of 3-dimensional objects is surface area, and similar to perimeter, right? Surface area is just the outer, right, area that it takes up, whereas the volume is the whole space that it fills up.
Next thing, blood drawing.
Oh, delightful. Okay,
I just don't know what time we close.
no worries. Put some water right before they drop.
Yeah, I've been drinking water a lot. the past few days. I got one of the clear tap things in my fridge.
Yep, that is virtually my friend.
Thank you for getting.
Oh, of course, no worries. All right. So how's everyone, is everyone feeling like you can work on these, or do we talk about them together? How about you folks on Zoom? Do you guys want to keep working on your own? Yes, no, kind of maybe. All right, I'll give you guys another 5 minutes or so to work on your own. Okay, sounds good. I don't mind. All right, yeah, I mean, this stuff, like, it's definitely, yeah. Like I said, trying to figure, I don't think I've seen like literal GED questions, but definitely just a useful skill. In general for,
Especially in the medical field, I feel like.
yeah. Yeah, we had to, like, my algebra teacher was the regular science teacher, so we did a lot of these because he's like, this is what we need to do in science all the time. All right, so we're gonna take our formula S equals 4 pi r squared. Okay, so this is our formula to calculate the surface area of a sphere. And right, they want us to solve in terms of R. Okay. So just like we kind of, if you went back to example 2, I believe, right, it would basically be the same process. This is 4 times pi times r squared. So, right, I want to divide by 4 pi, right? 1 over 4 pi. Okay, right, because that way my 4 and my pi cancel on this side. 1 over 4 pi times s, right, leaves us with s over 4 pi equals r squared. Okay, and then what do we have to do to get our r, just an r? This is r squared. What's the opposite of squaring? No? Square root, right? So then we just take the square root of both sides. The square root of r squared is r. So we know R equals the square root of the surface area divided by 4 times pi. Just answer B. Oh, yeah.
Thank you.
How's number 2 feeling? All right. So number 3, the formula to convert a temperature from degrees Celsius to degrees Fahrenheit is, right, the temperature in Fahrenheit is equal to 5/9 the degrees in Celsius minus 32. Okay, so then it says solve the formula for C. Okay, so we have F 5/9 times the quantity C minus 32. So we need to get C by itself. Okay. So the first thing that I can do, and I don't need to distribute this, what can I do to move this chunk away? No, this is multiplied by this. Divide by what though? This is a fraction, 5/9. Yep, yep. Exactly, right? Take the reciprocal, which is 9/5. Right, so we're gonna multiply both sides by 9/5, right? And these are gonna cancel. So now I have 9/5 F equals C minus 32. Okay, now what should I do? So if this is, we need C by itself, C minus 32. Very good. So now I have, right, 32 plus 9/5 F equals C. I think that's right. Okay. Good. So C equals 9/5 times F plus 32. Okay. So of course, if you're going abroad, you might need to, right, use this to calculate the temperature if you're not good at knowing what Celsius temperatures mean. Okay. All right. Number 4 is one of our proportions. So the dosing instructions for a medication are to give 30 milligrams per 50 pounds. The equation 30:50 as D is to W relates the dosage of milligrams D in our, to the patient's weight in pounds W. Solve the equation for D, okay, in simplest form. So that's our first step. All right, so we have 30 over 50 Now, if you've been in our Monday, Thursday morning class, you might be familiar with this. But when we have it set up like this, we cross multiply, right? So 50D equals 30W. Okay. It's cross multiplying, so 50 times D is 50D, 30 times W is 30W, and then we're solving for D, so then I should divide both sides by 50. Okay, so that D equals, right, 30W over 50. Now, is 30 over 50 simplified enough?
No.
How can we reduce this?
30 divided by 50.
Well, what's the highest number I can divide out of both the top and the bottom to reduce the fraction? Anyone know this one? So, especially when you have zeros, you can just shave them off if they both have a zero. But really, we're just dividing out 10 from the top and the bottom, right? Because 30
Oh.
divided by 10 is 3, 50 divided by 10 is 5. So the simplest form, right? D equals 3/5 W, right? So what does this tell us about the relationship between the dosage and the person's weight? Guess? Which is equal to 3/5 of the person's weight, although it's between milligrams and pounds, so that doesn't make any sense. Okay, and then we'll do the same thing for W. So it's just kind of the opposite of what we just did, right? So we still set it up the same way, but now we have, right, 30W equals 50D. And then we're dividing the 30. So we know that W, right, equals 5. Does that make sense?
Yes.
All right. Good working, guys. I know this isn't like the most interesting, but hopefully you're feeling like you're seeing how we're manipulating these things. Okay. Famous science example. The density of an object V is equal to the ratio of its mass to its volume. The equation density equals mass divided by volume models the relationship. So we need to solve the equation for M. So if we know that D equals M over V, what should we do to get M by itself? Yeah, what do we need to do? So if this is M divided by V, what should we do with V to get rid of it on this side? It's being divided. Multiply. Good. So I'm gonna multiply both sides by V. Right. So we know that, right? M equals D times V. Solve the equation for V. Again here, right? So now, right, I do, oh, this one. What should we do here? Yeah, I think it's just.
I'll multiply it by M.
Well, the M is on top. I think here's where we might want to use the reciprocal, right? Because if we multiply No, that'll cancel both. Okay. Cause then, right, so if we divide both sides by m, then we have d over m equals 1 over b. Man, I'm sorry, I got stuck. Like, wait a minute. I knew it was gonna be funky, but. Brain, I think I caught whatever Spencer's brain has.
I think a lot.
Okay, yeah, so. So yeah, really like. How do I make that work? Because it should be b equals m divided by 2, right? Yeah, I'm not exactly sure why or how I'm just supposed to split this, but it flips. I'll have to get back to you guys on Monday on this one, okay? But yeah. All right, if you want to continue trying to work out number 6, we can start there on Monday. And like I said, this isn't too super important, but it's definitely an important skill to know. And so hopefully you felt like you kind of knew what to do. Just a second, Kaylee.
The second YouTube video didn't work,
Oh, okay.
so I just guessed on the first question.
That's fine.
So. A lot better than I thought I was gonna do.
Yeah, definitely practice those negative, adding negative and positive numbers. Terms.
I've definitely improved also from my high school course to now.
Okay. And then, yeah, did you try the practice test again or not?
No, I haven't tried it. I've been really busy lately, so.
You're not. I understand.
And then I also have another worksheet that you've given me quite a while ago.
Uh-huh.
I'm trying to finish that up. It's kind of confusing for me, but I'm getting it.
All right,
So
good. Stick with it and always can bring questions. Yes.
Next week, they're doing a survey for.
Okay.
So I'm not trying to jump on that.
Okay. Yeah, I can understand
I'll
that.
bring some pictures back.
Okay, cool, sounds good,
I'm gonna try tomorrow
okay,
after work.
great. And social studies teacher. All right, any questions or concerns from you folks on Zoom? Any comments at all? Hopefully you guys are live. You're always more than welcome to interact with us more. I just feel like I'm demoing stuff to you guys, but any input is welcome. Okay. All right. See you guys. Maybe tomorrow, if not next week.